Welcome back to Lecture 2 on Gravitation and Harmonic Motion. Today we're going to be looking at two different types of harmonic motion with two different objects, pendulums and springs. You notice the equations that we're using are close, the t and the 2 pi, but underneath the radical, a pendulum, you got L and G. L is your length, G is 10, as we know. And under the spring, I got M for mass, and K is our spring constant, which we've covered in past lectures. If you just want to review, here's our units. The length is in meters, since that's a distance. And mass, we know it's in kilograms. Spring constant is newtons per meter. Remember, spring constant is the force needed to compress or stretch a spring. In some books, they have this as a lowercase l, but most of them do have this because what happens with the L, it gets scrunched and it almost looks like an E in somebody's writing. But what they do, they print it nice large L. You notice this one is a small g, not like the big G that was in the gravitational constant equation in the lecture 1. So be very careful of how you write things. So we're looking for the period, in other words, how much time it takes for one cycle or one oscillation to occur. And it's really on this, it's just, okay, let's read, and this is pendulum. So we got to use our pendulum equation. So T is equal to 2 pi, and that's L over G. Remember, the radical goes over both of them. Don't get sloppy and make it just look like the L. Your teacher will probably count off for it. So we're looking for the period. So T, 2 pi, and this is 1.5. And since we're dealing with Earth, we're going to understand that's Earth. Now, if it was on another planet or another body with a different gravitation, your teacher would have you would have to have that for you, or you may use it to calculate the G, which is a nice classic physics experiment. And since T is periods in seconds. And says, what is the length? Okay, pendulum. Please do not use the spring equation for a pendulum. And L over G, I want to know L, so I need to, okay, I got seconds, 2 pi, make sure that radical covers everybody, L over 10. And length, as we know, will be in meters. So, pendulum equation, there it is. If you see the word pendulum and you see a period or you're looking for the length, use this equation. So let's kind of go to the side. These side ones, okay, you notice these says springs, not pendulum. A little different in the wording. So, since this is a spring, we want to know the period. So T is equal to 2 pi M over K. Okay, we want the period, so that's 2 pi. Make that sure your radical covers everybody. The mass is 115, spring constant is 800, and the T will be in seconds. Pretty straightforward. Please read the problem. Now we can use this one. Okay, you see spring. It has a period with a mass. So T is equal to 2 pi M over K, and I want to know the spring constant. This is another little classic physics. Got a little carried away, start talking and not writing, and sometimes hard to do two at the same time. So the period is 4.33. You can see the reason why it's better to do physics or any type of math problems in a pencil. Much nicer and a lot easier to erase. So M is 13, I want K. Please be very careful. Okay, so K, that's little k, not big K. And that's a spring constant, so that's going to be newtons. Remember, that's a print N over M. So you can see on this, finding the period, or for a pendulum, the length, or on a spring, if we know we got period, mass, and spring constant, and you got to give 2. It's just being able to look at, okay, spring, pendulum, 2 different words, look a whole lot different, so be careful, and please don't use one for the other. Your teacher will probably be a little bit mad at you. Remember, if you have any questions, feel free to contact me.